Actually, yes, a tool for monitoring and profiling OCaml programs, but it's actually a library. It's both a tool and a library. So it's a library that you're using to annotate your programs. To see, you're going to say, well, I want to profile this thing, or to debug this thing, and then it provides you a tool to have to visualize this information. Ocamlviz, the development of Ocamlviz has been funded by Jane Street Capital. So that was a Jane Street summer project, and that was actually the project of two students, Julien and Guillaume von Tokarski. And this project has been supervised by Jean-Christophe Filliâtre, Fabrice Fessant, and myself. Okay, so this project starts with a very naive question. How do you tune or debug an OCaml program? So if you ask this question to any OCaml programmer, okay, how do you debug your program? So, well, first maybe I'm going to add some printf instruction in my program. So that's a nice way. So it provides you nice traces. Yeah, that's right. So but if these traces are not enough, you can use, for instance, OCaml debug. So under Emacs. So you can stop your program and you can inspect the value of the variables, and you can also go backward the execution. So that's a very nice tool. And if you want to profile your OCaml program, so what you can do is to use the time or top command of Unix, for instance. So time gives you the execution time of your program at the end, and of course top can give you at real time the amount of memory that your program is using. But if you want to profile your program a little bit better, so what you can use is OCamlprof. So that's also a nice tool. It records execution, counts for specified part of the program. So for instance, you can count the number of times the program has reached a then branch or an else branch of an if then else, or match instruction or function call, and so on. And actually, you can also use more generic profilers, such as gprof, for instance. Gprof actually gives you an extra information, which is the time spent inside a function, for instance. And you can even have real-time information using OProfile. So there are several tools to debug or profile OCaml program. But actually, this tool seems very complementary, but they are suffering from several drawbacks. So for instance, the debugging tools have no nice display. Well, at least I know that a lot of people like Emacs, but actually I think that's not very, very nice. At least that's not graphical. And you don't have real-time analysis. Okay, you have to stop your programs to see what are the values of your variable. Now, usually, if you want to have profiling information, you have to wait for the termination of your program. And you don't have a lot of memory profiling. For instance, you suppose that you want to know exactly what is the amount of memory used by some values in your program. So you have limited observation. And furthermore, OCamlprof only works for bytecode programs, while gprof uses native code. Is okay for native code. So, well, what we wanted to do is to fill this gap. But so we wanted to provide real-time monitoring, a fine-grained and customized observations, a nice graphical user interface to display all these results, and also we wanted to be able to monitor these programs remotely and at any time. So you can run your program and decide after 5 minutes to see what happened in your program. So in this talk, I will give an overview of Ocamlviz and some implementation details. So let's start with a very naive view of Ocamlviz. So what you have is an instrumented program. So using this Ocamlviz library, as I said, you can instrument your programs. And then Ocamlviz also add to your program some server capabilities. So that clients remotely can connect to your program and get some profiling or debugging information. So, okay, there is a picture here, but let me start with a demo just after the next slide. So, okay, suppose you have a program, and in just one line you want to know, to have some information about the GC activity of your program. So, you have to link with Ocamlviz, and for that, you just have to add one line in your code, ocamlviz.init. Okay, so let's start with this demo. So for this talk, I will use this very this is a simple program, but that's a pure lambda calculus version of quicksort. So
I've always wanted to debug that.
yes, or even to profile it. It is used to sort lambda term that encodes lists of integers. So at the end of this program, so here, or maybe nobody. Okay, so here, I have a list, and I want to show that so after this quicksort, by applying quicksort, the list is actually sorted. Of course, so in this program, we are using hash consing and memorization to do something faster. So if I just do nothing for the moment. So okay, I'm compiling this this program. So well, for the moment, I'm just oops. No. Thank you. Okay. I should have read this in a makefile, maybe. Okay, so I'm running this program. And nothing happened. Okay, so I don't know what's going on. So I'm just adding this instruction. Recompile my file, that's okay. Now I'm running it. And then I'm running this Ocamlviz graphical user interface.
Maybe you have to recompile it.
It has been recompiled. So here I have this graphical, this GC activity. So I have the total size of the heap and the living bytes of in my program. Okay, so we just in one line. Okay, that's for the beginning. Now. Ocamlviz provides, for instance, modules to monitor program points and duration. So, suppose you want to know how many times you reach a given point in your program. So, what you can do is to create a point using ocamlviz.point.create, and you give a name to that point, here P. So, that's my point. And then I can use this point everywhere in my program. So, for instance, I have a function f here, and I want to know when this function is called. So, I just observe this point P here at the beginning of f. So, I'm calling ocamlviz.point.observe P, and then each time P is reached, I'm going to see this in my Ocamlviz graphical user interface I have the point P and the number of time P has been reached. So I can also create timers. So using Ocamlviz.time.create, I give a name to that timer too. And then I can just start timer and stop them anywhere. So for instance, I have a function f here. And in this function, I'm starting the timer t. And I decide to stop this timer in the function g. Okay? So that's our fine-grained observation. You can also observe values. For instance, so we have some predefined function for that in the library. So if you want to observe a function that returns float, for instance, you can using Ocamlviz.value.observe float function. So you can observe any function that returns a float. So here I'm giving a name my value to that function, and that function returns a sign, for instance, of this value v. And then I can also observe the reference of float reference. Okay, so let me show this in a demo. So for instance, in this program, so for instance, here I have a function term.stat that gives some statistics about the number of hash const term in my library, and I want to observe this function. So this function returns a lot of things, but I'm just interested in the third one, s. So I'm just calling observe in function in my library. I give a name to that value. Here I can also specify at which rate I want to observe this function. And then I recompile the program, run it. I'm running the GUI. And then here in this hash const term, I have the number of term hash const in my table. So I can create a graph for that. I can detach it. I can have the GC activity also somewhere. Okay. Okay. All right. So now, yeah. So I can even observe the complex values within with Ocamlviz. So for instance, if you want to observe more than integer, float, or string, for instance, well, you have to do a little bit of work. So what you have to do is to turn your data structure in our tree type. So we have provided a kind of a type for describing trees. So this type is described in the protocol module. It has this is a record with two values, so variant name and variant children. So for instance, if you have a type T with two constructors, A and B, A takes string and B two values of type T. So what you have to do is to give a value a function transform that will transform this value, any value of type T in this type. And then what you can do is just to call Ocamlviz.tree.observe to observe, for instance, here a function that transforms a value in this type. So what you get in the graphical user interface is this kind of thing. So if your value, so your value is going to be represented as a tree. So it is important to notice that sharing is preserved during the marshalling part of the value. Okay, and so that's a way to visualize more complex values. But the programmer still have to do some work, of course. There is no black magic here. So now, if you want to profile memory, what we provide for that is the notion of tag. So you can create a tag using the tag.create function. You can precise that you want to know. So these tags are going to be used to tag values of any type. So a list can be tagged with the same tag than a float or something like that. So for instance, here I have a list of two float numbers, and I'm tagging this list with the tag t. Okay. Here I'm tagging the result of the function f using this tag t again, and here I'm also tagging this triple with t. So when I've created this tag, I said here that I wanted to know the size of, so the amount of memory that is used by values which are tagged with this tag t. And here again, that's the period that the rate, that's the rates, because we don't want to observe a value at each n second. For instance, you have to precise exactly when you want to, at each, what rate you want to observe value. And we have also provided a way to observe, to profile data structure that are in the OCaml library. So for instance, for htable, you have directly a function ocamlviz.htable.observe. So each time you create an htable, you can just specify that you want to observe this table, you give a name to this, and you will immediately have actually all this, well, a lot of information about this htable, such as the number of elements, the number of empty buckets, and the filling rates, and all that stuff. So for instance, in my program, because we are using memorization in this program, I have this hash table here that is created. So I just want to observe this table. So I'm calling htable.observe using this name memo term, and I recompile my program, run it, and then here I have immediately some information about this hash table. Okay. So, for instance, I can visualize the number of elements. I can also, for instance, want to know the entries. So here I can visualize this entry in the same graph. Oops. So you have two. Oops. Okay. And I can still observe the GC activity. Okay, and sometimes that's interesting to see that, for instance, okay, something happened here. Okay, so a lot of term has been created, so on. Okay. Okay. And we still, of course, that's always possible to add some printf-like function within Ocamlviz. Okay, so using this Ocamlviz.log function, you can still log your program. Yes, have some basic traces, and actually, what Ocamlviz provides is the time when some trace happen. So, some additional feature about the graphical user interface. So we have this recording mechanism. You can pause and go backward and forward in the execution. But actually, your program is not stopped. Okay, what you are stopping is the visualization of this information. Okay, so just a few words about this performance overhead. So. With reasonable server settings. So what does that mean? So first of all, when you are just linking your program with Ocamlviz, and so what you get for free, as I said, is the GC activity. So it impacts only. So suppose you have no client for the moment, so you're just linking your program and run it. Okay, that's all. That's it. So that's just 1% overhead, less than 1%. Now, if you connect one client, remotely or not, that's not a problem. So it's about 6%. The impact is about 6%. Okay. Now, if you reasonably instrument your program, so what does that mean? So you're not going to observe all the functions, all the values, and all that stuff. So okay, so you're doing something very reasonable. So I don't know, maybe 5 functions, 2 hash tables, something like that. So that's so without any client, the impact is only 2%, and when you're connecting a client, it's more than 10%. Of course, well, actually, this number said nothing very interesting, I think, but we have used Ocamlviz for our own program, and sometimes we wanted to know some information. Okay, usually that's not a lot, 4 or 5 information, and that's actually the kind of number we get. Okay, so that's it. Okay, now I'll give some implementation details about the communication protocol. So the whole picture is this. So you have your instrumented program, and what the library does is first to collect information in your programs where you have specified when you have specified the profiling and debugging point. It uses two kind of techniques it can use two kind of techniques to collect this information. It can use alarms or threads. Okay, you have to choose between the two libraries for that, and then it provides also some server capabilities. Then all the values are transmitted using a binary protocol to a client, and Ocamlviz also provides a database module that stores all the information that are transmitted. And then we have two tools for the moment, a graphical tool and an ASCII tool. And we also have some CamlP4 experiments. So I think that if you want to have more information about that, just ask Fabrice. This module tries to, for instance, if you want to monitor all the top-level functions of your program, you can use these facilities for that, this CamlP4 module for that. So maybe just one word about the binary protocol. So that's a protocol that has been designed to save bandwidth. This protocol is documented, and it is architecture independent and compatible with a 32 or 64 bits architecture. And furthermore, it is OCaml independent. So what that means is that you can write servers in other languages than OCaml, and still use this. And if you are transmitted values using this protocol, then you can still use our graphical user interface to show the results. Or you can, of course, write your own client, and it still works. It should still work. Maybe I should skip some details. Yes, just one word about this alarm and thread stuff. So we are providing two libraries to collect data, to collect and send data. So first we have used an alarm-based solution. It is quite efficient, but of course, because there is only one handler per alarm, this handler may conflict with a user's handler. If you're using alarm in your program, that could be impossible to use this technique to monitor it. So you have to switch to a thread-based alternative. But it should be important to notice that context switch for threads seems to be less efficient than for alarms. Okay, so, but in these two solutions, we still have some fairness issues. Signal handling or thread scheduling only occurs at allocation or input-output operation. Okay. So suppose you have to have a program that does not allocate a lot or just do no input-output operation. Well, for this kind of program, we have provided a function, yield, that have to be used to enforce OCamlviz to observe values. Okay. So, so about this observation technique. So, collecting data for program sprites and timers is not difficult. But what is more difficult is to collect data for tag values. Okay. So, what we need is to count the number of live values and to count the total size of these values. So what we have used, of course, for that kind of thing is to use weak hash tables. So let's make just a very simple experiment. So suppose you declare a weak hash table like this. So using this this functor make in the library weak. So the type T is obj.t. You are using hash table.hash, the generic hash table.hash function, and the equality function, okay, physical equality function. If you're just using this kind of weak hash table, that will not work. So we can just do it. So you create a weak hash table, then you suppose that yes. We declare V to be the representation of the list which contains just one integer. Then we are adding a V in T, and we are calling the function mem to see whether V is in T, and the answer is false. Okay, so that does not work. So actually, the problem is that the function the function mem compares copies of the values which are pointed by weak pointers. So using this physical equality function will not work. So what we have done is to, well, our solution was to duplicate the outermost block of the values and to share the inner pointers. Well. Okay, so maybe I have to stop. So yeah, I'll skip this. So of course I'm going to give you the slide so you can find all the information in the slide. Okay, so what's the conclusion? Ocamlviz provides many features to profile and debug your OCaml program. It is modular, and we think that it can be easily extended. And we think that it does a lot more than existing tools. So you can download this program at this address. There are a lot of possible extensions, of course. For instance, it could be very interesting to know to have information about the time spent in the garbage collector. It could be also interesting to add breakpoints. Okay, to stop, ready to stop the program. And we can also add some bidirectional communication. So the client could really want to say, okay, this I want now to stop the visualization of this value. Okay, I know enough about it. Something like that. That's it. Okay.
Any questions?
I have two questions. The first, is it possible to debug? Is it possible to debug cyclic data structures?
Yes, I think so.
Okay. And second, is it possible to debug a server? I mean, how the server capabilities that are injected in my program when I link Ocamlviz interacts with, for example, the main loop of my server. For example, a fast CGI server or an HTTP server or something like this. Thank you.
Well, I think that's possible to profile a server. I mean, yes. The library is always able to get the information about the values that you want to profile in your program. So even if your program is a server, that will not make a difference, no? Yeah.
Well, I think that could make a difference when the server is multiprocessed.
Pardon.
I think that could make a difference when the server is multiprocessed. So when it forks off children and the children do the real work.
That's what I was thinking about that.
Yeah.
Yeah, maybe. Yeah.
Did we finish to debug the problem at the beginning? Because it didn't return anything. Didn't the program at the beginning? It didn't return anything.
Quick source.
Yes. There was no bug in this program, so it was just slow. That's it. Thank you.